According to the 2002 National Electrical Code, if outlets are added or brought up to code from non-grounded, the room must be on an arc fault circuit interrupter, or AFCI. The code reference is 2002 NEC 210.12b. This section specifies the requirements for arc fault circuit protection. AFCI protection is intended to mitigate the risk of electrical fires caused by arcing faults in electrical wiring. These faults can occur due to damaged insulation, loose connections, or other factors that create unintended paths for electrical current. 2002 NEC mandates AFCI protection in specific locations within a dwelling unit to enhance safety and reduce the likelihood of fire. If there are no smoke detectors currently installed, new ones must be hardwired according to the 2002 NEC. The relevant code reference is 2002 NEC 706C.41a. This section deals with the installation requirements for fire alarm systems, including smoke detectors. The requirement for hardwiring smoke detectors ensures that they are reliably powered and functional, even during a power outage. This is a critical safety feature, as smoke detectors are essential for providing early warning of a fire, allowing occupants to evacuate safely. To further elaborate on AFCI protection, it is important to understand the types of circuits that typically require this protection under the 2002 NEC. Generally, AFCI protection is required for branch circuits that supply outlets in bedrooms, living rooms, dining rooms, family rooms, recreation rooms, and similar areas. The purpose is to protect these living spaces where occupants are most likely to be present and potentially vulnerable to the hazards of an electrical fire. An arc fault circuit interrupter is a type of circuit breaker that is designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. AFCIs work by monitoring the electrical current and identifying abnormal arc patterns. When an arc fault is detected, the AFCI quickly trips the circuit, interrupting the flow of electricity and preventing the arc from escalating into a fire. There are two main types of AFCIs: branch or feeder AFCIs and outlet branch circuit AFCIs. Branch or feeder AFCIs are installed in the electrical panel and protect the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet on the branch circuit and protect the wiring downstream from that outlet. The 2002 NEC permits the use of either type of AFCI to meet the requirements for arc fault protection. However, outlet branch circuit AFCIs are often preferred because they provide more localized protection and are easier to install in existing homes. When upgrading existing wiring or adding new circuits, it is crucial to ensure that the AFCI protection is properly installed and functioning correctly. This includes verifying that the AFCIs are compatible with the existing wiring and that they are properly grounded. It is also important to test the AFCIs regularly to ensure that they are tripping as intended. Regarding smoke detectors, the 2002 NEC specifies that smoke detectors must be hardwired to the electrical system and interconnected so that if one smoke detector detects smoke, all of the smoke detectors in the dwelling unit will sound an alarm. This interconnection provides early warning to occupants throughout the house, even if the fire originates in a different part of the building. In addition to being hardwired, smoke detectors must also have a battery backup to ensure that they will continue to function during a power outage. The battery backup should be tested regularly and replaced as needed. The 2002 NEC also specifies the location requirements for smoke detectors. Smoke detectors must be installed in each sleeping room, outside of each separate sleeping area, and on each level of the dwelling unit, including basements. The purpose of these requirements is to provide comprehensive smoke detection coverage throughout the house, ensuring that occupants are alerted to a fire as quickly as possible. When installing smoke detectors, it is important to follow the manufacturer's instructions and to ensure that the detectors are properly mounted and connected. It is also important to avoid installing smoke detectors in locations where they may be prone to false alarms, such as near kitchens or bathrooms. In these areas, heat detectors may be a more appropriate option. Heat detectors are designed to respond to rapid increases in temperature and are less likely to be triggered by cooking fumes or steam. In summary, the 2002 NEC requires arc fault circuit interrupters for certain outlets when they are added or brought up to code, and it requires hardwired, interconnected smoke detectors with battery backups in specific locations throughout the dwelling unit. These requirements are intended to enhance electrical safety and reduce the risk of fires. Always consult with a qualified electrician to ensure that your electrical system meets the requirements of the 2002 NEC and any other applicable codes and regulations. Furthermore, understanding the specific details of the code requirements is essential for ensuring compliance and maximizing safety. For instance, 2002 NEC 210.12b outlines the specific areas within a dwelling unit where AFCI protection is mandatory. This includes not only bedrooms but also other living areas where occupants spend significant time. The code aims to protect these areas due to the potential for occupants to be asleep or otherwise less aware of their surroundings, making them more vulnerable to the hazards of an electrical fire. It is also crucial to consider the types of outlets that require AFCI protection. Generally, all 120 volts, 15 amps and 20 amps branch circuits supplying outlets in the specified areas must be protected by an AFCI. This includes general-purpose receptacles, lighting outlets, and other electrical devices. The intent is to provide comprehensive protection against arc faults throughout the branch circuit, minimizing the risk of fire. In addition to the specific requirements for AFCI protection, the 2002 NEC also includes general requirements for electrical safety. These requirements include proper grounding and bonding of electrical equipment, proper installation of wiring and devices, and protection against overcurrents and short circuits. It is important to comply with all of these requirements to ensure the safety of the electrical system. When it comes to smoke detectors, the 2002 NEC requirement for hardwiring and interconnection is intended to provide a reliable and effective fire alarm system. Hardwiring ensures that the smoke detectors are powered by the electrical system, providing a continuous source of power. Interconnection ensures that all of the smoke detectors in the dwelling unit will sound an alarm if any one of them detects smoke, providing early warning to occupants throughout the house. The requirement for battery backups is also crucial, as it ensures that the smoke detectors will continue to function during a power outage. This is particularly important, as power outages can often occur during emergencies, such as fires. The 2002 NEC also specifies the types of smoke detectors that are acceptable for use. Generally, smoke detectors must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. This ensures that the smoke detectors meet certain minimum standards for performance and safety. In addition to the requirements for hardwiring, interconnection, and battery backups, the 2002 NEC also includes requirements for the placement of smoke detectors. Smoke detectors must be installed in each sleeping room, outside of each separate sleeping area, and on each level of the dwelling unit, including basements. The intent of these requirements is to provide comprehensive smoke detection coverage throughout the house, ensuring that occupants are alerted to a fire as quickly as possible. When installing smoke detectors, it is important to follow the manufacturer's instructions and to ensure that the detectors are properly mounted and connected. It is also important to avoid installing smoke detectors in locations where they may be prone to false alarms, such as near kitchens or bathrooms. In these areas, heat detectors may be a more appropriate option. Heat detectors are designed to respond to rapid increases in temperature and are less likely to be triggered by cooking fumes or steam. Furthermore, it is essential to understand the difference between smoke detectors and carbon monoxide detectors. Smoke detectors are designed to detect smoke, which is a byproduct of fire. Carbon monoxide detectors are designed to detect carbon monoxide, which is a colorless and odorless gas that can be produced by burning fuels such as natural gas, propane, and wood. Carbon monoxide is a deadly poison, and exposure to high levels of carbon monoxide can be fatal. The 2002 NEC does not specifically require carbon monoxide detectors, but many local jurisdictions do. It is important to check with your local building department to determine whether carbon monoxide detectors are required in your area. If carbon monoxide detectors are required, they must be installed in accordance with the manufacturer's instructions and any applicable local codes. In addition to complying with the 2002 NEC, it is also important to follow any other applicable codes and regulations. This may include local building codes, fire codes, and electrical codes. It is also important to consult with a qualified electrician or building inspector to ensure that your electrical system meets all applicable requirements. When making electrical upgrades or renovations, it is always best to err on the side of caution. If you are unsure about any aspect of the electrical code, it is best to consult with a qualified professional. In addition to the specific requirements for AFCI protection and smoke detectors, the 2002 NEC also includes general requirements for electrical safety. These requirements include proper grounding and bonding of electrical equipment, proper installation of wiring and devices, and protection against overcurrents and short circuits. It is important to comply with all of these requirements to ensure the safety of the electrical system. Proper grounding and bonding are essential for preventing electrical shock hazards. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit. Bonding connects all of the metal parts of the electrical system together, ensuring that they are at the same electrical potential. Proper installation of wiring and devices is also crucial for preventing electrical hazards. Wiring must be properly sized for the load it will carry, and it must be installed in accordance with the manufacturer's instructions. Devices must be properly mounted and connected, and they must be protected from physical damage. Protection against overcurrents and short circuits is provided by circuit breakers and fuses. These devices are designed to trip or blow when the current in a circuit exceeds a safe level, preventing damage to the wiring and equipment. In summary, the 2002 NEC includes a comprehensive set of requirements for electrical safety. These requirements are intended to protect people and property from electrical hazards. It is important to comply with all of these requirements to ensure the safety of the electrical system. Consulting with a qualified electrician or building inspector is always a good idea to ensure compliance with all applicable codes and regulations. Also, bear in mind that electrical codes are regularly updated to reflect new technologies and safety standards. While the 2002 NEC provides a solid foundation for electrical safety, it is crucial to stay informed about the latest code revisions and amendments. Subsequent editions of the NEC may include changes to the requirements for AFCI protection, smoke detectors, and other electrical safety measures. Staying up to date with the latest code requirements ensures that your electrical system meets the highest standards of safety and performance. Electrical work should always be performed by a qualified and licensed electrician. Attempting to perform electrical work without the proper training and experience can be dangerous and may violate local codes. A qualified electrician has the knowledge and skills necessary to ensure that electrical work is performed safely and in compliance with all applicable codes and regulations. They can also provide valuable advice on how to improve the safety and efficiency of your electrical system. In addition to the technical aspects of electrical work, it is also important to consider the administrative requirements. This may include obtaining permits, scheduling inspections, and complying with other local regulations. A qualified electrician can help you navigate these administrative requirements and ensure that your electrical work is properly documented and approved. Remember, electrical safety is not just a matter of complying with codes and regulations. It is also a matter of personal responsibility. Taking the time to learn about electrical safety and to follow safe practices can help protect you and your family from electrical hazards. This includes being aware of the potential hazards of electricity, such as electrical shock, fire, and explosions. It also includes knowing how to respond to electrical emergencies, such as a power outage or an electrical fire. By taking a proactive approach to electrical safety, you can help create a safer home for yourself and your family. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or building inspector before making any electrical upgrades or renovations. They can provide you with specific recommendations based on your individual circumstances and ensure that your electrical system meets all applicable requirements. Ignoring potential electrical problems can lead to significant consequences, including property damage, injuries, and even fatalities. Addressing electrical issues promptly and professionally is a vital investment in the safety and well-being of your home and family. Understanding electrical codes, like the 2002 NEC, is an ongoing process requiring continuous learning and adaptation. The electrical field is constantly evolving with new technologies and best practices.